Hi everybody, welcome to another video coming at you. Mr. Roberts here. Hey, for this video it's going to be a little bit different of an assignment. We're going to take a deep dive into our study of light, and for this assignment you're going to be watching me take some notes, and all I'm asking is that you copy these notes, take some sort of image or picture, some sort of photograph, upload those back up to Google Classroom. And there'll be a slide in there. Just insert your image of your notes in that slide. All right, so here we go. We're going to take a deep dive into our study of light. And the first thing I want to talk to you about is this notion of light. Because in science terms, really a lot of times what you'll hear scientists call light is something called the electromagnetic spectrum. So, go ahead and write that down. Your page should look like mine for this assignment. So, I'm not quite sure why we call light in our entire unit of study when it's actually called the electromagnetic spectrum. I think it's because it's a big word and it means a lot. Let's break it apart though. So we have electromagnetic, okay? So that's electricity and magnetism. And one thing you can think of light as is a wave. And that's the name of our unit, is light waves. So what does that mean? Well, if you can think of a wave, kind of like I've got this wave here, okay? This could be the electro part of electromagnetism. This is our electric field wave. Well, in order for light to occur, there also needs to be a magnetic wave, but it doesn't just ride with the wave, it actually sits sideways. This is called transverse. So one wave is just like you see here, but the second wave is actually 90 degrees across, just like this. And that's when we say the electromagnetic waves or the electromagnetic spectrum or light waves, that's really what we're talking about. In our last unit, we learned that there was a relationship between electricity and magnets. And if we slide a magnet across a conductor, we can actually generate an electric field. Kind of like this here, you can see the light is actually being generated from the electricity. Same thing with this little gadget here. There's a motor inside of here with magnets and a conductor, and if we move those conductors along the magnet or vice versa, we can see that light is generated. So really what I'm getting at is that electricity, magnetism, and light are all connected. So for this next part, I want to talk to you about waves. So we know that there are things called waves and that light travels in these waves. Well, there's different kinds of light out there. So if we have a low frequency, so you can see there's not very many waves on the card here. So we would call that a low frequency. But there's also high frequency waves. And you can see there are several waves on that card versus the low frequency wave. Well, all of these happen in something that we call the electromagnetic spectrum, and it really kind of looks like this. So it starts off, and then it starts getting tighter and tighter and tighter and tighter, all the way to the end. And that's what we would call the electromagnetic spectrum. Now, along here, there's different frequencies, right? So this is a frequency, and it changes, and it gets tighter and tighter as we go. Well, what we've seen is that as there's a change in frequency, that equals a change, delta just means change, and you can write the word change if you want. That equals a change in the kind of light. And so let's dive in and go a little deeper. What are some different kinds of light that we have? Well, on one end of our spectrum, where the waves are the largest, we have something called radio waves. And you guys might be familiar with radio waves, right? We have these things called radios, and they pick up sounds from, let's see, how do we draw a big old tower out here? We know that radio waves can transmit sound through the air. Well, that's actually just light. Those are a form of light waves. We also know that there's something called microwaves. And those happen next in our spectrum. And we know about microwaves, right? We can cook with those. Let's see, there's my little window. There's my little box. We can cook with those. We can also use these for communication, for radar. As we go further down, we have something called infrared. Now, infrared we use for things like cooking. So let's say you've got your stove top here. You've got nummy things cooking and sizzling there. Another thing that you might see or you should know about infrared is it's actually heat. It's like for heat vision. Anytime you see anything like that, that's really just infrared light. Next up, we have the one we all know about, the first one we learned about, and that's visible light. So we've got this visible light, and you guys already know so much about it because we make sure that you do in kindergarten, right? We've got red, orange, we've got yellow, green, I have some indigo, and then some violets. And this small little chunk in the middle, this is actually the only part of this band that we see. Notice here we have infrared. And right next to our visible, right on one end of our visible light spectrum, we have infrared, and red is right here. Well, this is Latin, but infra means below, so this is a lower frequency. Right? These are bigger. And then we have ultra, which means above, so a higher frequency. And that is actually our next one, is ultraviolet. And ultraviolet is really important to us for what we're studying right now, because we know all about, or we're learning all about, how the sun can cause skin cancer. And ultraviolet, let's see, let's get this guy laying out on the beach, just hanging, getting his suntan, getting his ultraviolet radiation. Okay, next up on our spectrum are X-rays. X-rays. These are every superhero's favorite. Because we all want to have that X-ray vision. Now, X-rays, of course, we also use in medical procedures. We use those types of rays because they actually penetrate the skin, and we can see beneath the skin. So in dental exams, and of course if you fall down and you can't move your arm, of course the doctor's going to, well, let's get an x-ray and see if that bone is broken. Okay, last up are gamma rays. You got to be careful with gamma rays. This is what turned the Hulk into the Hulk, if I'm not mistaken. Gamma rays are actually the most lethal of all the rays out there. So this is our entire spectrum. The sun releases all of this all of the time, continually and constantly. Some of it will actually penetrate our bodies. Some of it will bounce off of our bodies. Some of it will be absorbed by our bodies. Now, what's interesting about all of this is light is always traveling at the speed of light. So that's about 300 million meters per second. And that's pretty much a constant. It can go a little slower if something's in its way, but generally this is about its constant speed for all of these waves. Now some of you might be wondering, well, how big are these waves? Because they do start off big and then they get really, really tiny over on one end of the spectrum. Well, radio waves are about the size of buildings. Microwaves are about the size of people. Infrared waves are lovely little things. They're about the size of butterflies. Visible light, those little waves as they're traveling along, they're about the size of a needle point. They're tiny, but they're getting a lot smaller as we go. Because ultraviolet, they're about the size of protozoans. So just small little tiny cell creatures. Next up, we have X-rays, and they are the size of molecules. And then those nasty gamma rays, they're about the size of atomic nuclei. So, as we round out the end of this discussion, I wanted to share this with you because we are talking about ultraviolet light. When we're doing the sims, you're seeing all of these different kinds of light, but I wanted to break it down to you. The key things to know is that different frequencies of light have make different kinds of light, and those different kinds of light have different properties. Some kinds of light we can see, and usually that's actually just visible light, so the only kind of light we can see. But there are many other kinds of light that we are interacting with on a daily basis that we don't see. They start off with radio waves, become micro, infrared, visible light, ultraviolet, X-rays, and gamma rays. Their sizes start off big and get incredibly small as we go. Buildings, people, butterflies, needlepoint, protozoans, molecules, and atomic nuclei. And no matter what happens, boys and girls, they're all going to be traveling in a straight line at the speed of light. All right, friends, I hope that was fun. Just remember, take a picture of your version of your notes from today's discussion and then post it in the Google slide that is in Google Classroom. I can't wait to see them.